We'll look at an example question. Now, before I do this, I just want to say there are many different types of questions and the approaches to solving them sometimes differ. We've not discussed all the approaches possible, but they're all based on the fundamentals that you have already learned, like relative speed and how to frame that initial condition correctly. That is the skill that you should be building. But this is just an example question where I can demonstrate the patterns that we've seen in the last couple of videos uh, can be useful in quickly getting the answer. And there might be questions where that method doesn't work. So you're not really done with circular track with just you know two videos and an example video. But let's just look at this example and see how it goes. Uh, Runners B and Q take 42 seconds and 105 seconds to run one full round. Lap time is given, the length of the track is not given, the actual speeds of the two people are not given. But let's see what happens. If they start simultaneously from the same point, find the time taken to meet for the first time anywhere if going in opposite directions, anywhere if going in same direction, at the starting point if going in opposite directions, at the starting point if going in the same direction. There are four different questions to be answered. The idea here with 1 and 2, the idea is they should meet anywhere on the track first time. 3 and 4, they're asking you when is the first time that they meet back at the starting point. So it's actually easier to solve 3 and 4 first. Anyways, let's me start off by saying that the times are on the ratio 2:5. Their lap times are the ratio 2:5. So their speeds are in the ratio 5:2. And this becomes important. Now, so you have a circular track. As far as 3 and 4 is concerned, doesn't matter the direction. Your lap time is 105 and your lap time is 42. Let's just look at opposite first. This means that they are basically P and Q. P is going to be at the starting point at every multiple of 42. The times at which P is at the starting point. Q's lap time is 105, so at 0, 105, 210, etc. Q will be at the starting point. For them both to be at the starting point, we need a time which is a common multiple of this 42 and 105. At every multiple of 42, P is at the starting point. At every multiple of 105, Q is at the starting point. So it's reasonable to say at every common multiple of 42 and 105, both of them will be at the starting point. So we're talking about common multiples. And the first time that this happens is obviously the least common multiple of 42 and 105, which you'll find out is 210. So at 210 seconds, both P and Q will be at the starting point for the first time. And so 210 seconds is the answer to the third question. Now on to the fourth question. It doesn't make any difference. You just remove this 42, put this on this side, same result. At every multiple of 42, P is at the starting point. At every multiple of 105, Q is at the starting point. So at every common multiple, they're both at the starting point. And the least common multiple is the first time that this happens. So the answer to the fourth question is also 210 seconds. Now comes the part where we invoke the results that we learned in the previous videos. Anywhere if they're going in opposite directions. Now, if you're going in opposite directions with speed ratios of 5 and 2, then that means 5 plus 2, 7 meeting points are there. And then the 7th meeting point is the first at the starting point, which we already found was 210 seconds. If the 7th meeting point happens at 210 seconds, the first meeting happens at 210 by 7 is equal to 30 seconds. So that's the answer to the first part. Now the second part. Second part simply says they are going in the same direction. What is the first time that they meet anywhere on the track? So then you will say 5 minus 2 is equal to 3 meeting points. This third meeting happens at the start, is the first at the start, which we already found to be 210 seconds. If the third meeting happens at 210 seconds, clearly the first meeting happens at 210 by 3 is equal to 70 seconds. And 70 seconds is the answer to the second part. Now, as I said before, there are many different ways of solving circular track questions. The prime reason that I favor the approach using lap time, which we have seen here, as I said, if you instead of lap time, if you have the length of the track as well as the speeds of the people, it would be possible for you to find the lap time from there and then apply this method. I'm not saying you should necessarily. There might be an alternative method where you can directly work with the track length and the speeds, but this is a more versatile approach as a result of uh, this conversion that is possible. This one particular approach will take care of most questions, if not all. But there are other approaches as well, and we'll look at those examples later as well.